Hello again, it's Mrs. Slauson, and we are on page 32 in your packet. So while you're going to page 32, I'll be jumping to page 30 because today we're going to look at how do you solve a quadratic in standard form. So what we did in the last video is we looked at what we would do if it was in factored form, and we used something called the zero product property. Today what we're going to do is we're going to work in standard form, and as you remember from the last two showcases of learning, that you do have the option to go from standard form to factored form by factoring. So that's what we're going to do. We're going to factor it so we can get it into factored form and then use that zero product property. Now there is another option, but that will be coming up for another video or two. Okay? So, jumping to page 32 again. There's a couple things to keep in mind when we do this. So how do we solve a quadratic in standard form? First, we have to make sure that it's in standard form, which means you got your highest degree first, so in this case an x squared, then the term with an x, and then the constant, and it's got to equal 0. So if it doesn't, you're going to have to get it in that form. The other thing is you do want that leading coefficient to be positive, your line leader, the one that's right in front. And so if it's not, that's going to change what your GCF will be if there is a GCF. And then you will factor completely. So just a reminder, what that means is a GCF, try it, doesn't mean it's going to happen. And then if there's two terms, see if it's a difference of squares, it doesn't mean that will work. Or if there's three terms, try the x and see if that works. All right? And then once we get it into our factored form, then we can set each factor equal to 0 and see what makes those particular x values make that factor worth 0. So just reminding that we're not going to go through all these examples. I'm just going to be touching on a couple of them. So on the very first one, it is in standard form, x squared then x equals 0. And so the first thing I'm going to do is factor it, is look for a GCF, and I can take an x out, and I can also take a 6, so I'm going to do that. And when I do that, and I factor the 6 out of this term and this term, I'm left with 3x and then minus 2. Since there are two terms still in my parentheses, I do want to see if it's a difference of squares, and although it's a difference, 3x and 2x are not perfect squares, which means they're not going to have nice square roots. So what I'm going to do is set now each factor equal to 0 because it's factored completely. And what I'm doing again is called the zero product property, and I'm going to solve for x. And it will take one or two steps. So in this step, to get x alone, I would divide by 6, which just leaves me with 0 as one of my solutions. And in this one, it will take two steps. First, I'll add 2 to the other side, and then I'll divide by 3, so that my answer is 2/3. And just a reminder, this little 2 means we will be having 2 answers for all our problems. So the next one I want to talk about with you is this one, because it is in standard form and it equals 0, but my leading term, my leading coefficient, my line leader is not positive. So when I do a GCF, not only will I take out the x and a 7, but I really want to take out a negative 7x. So when I factor negative 7x out of each term, here I'm left with x, and on this one I'm left with a negative 3. And then I can check to see if this is a difference of squares, and it's not. X and negative 3, or negative 3, however you want to look at it, it's not a perfect square. So I have factored completely, and now I can set each factor equal to 0 and use the zero product property. So in this one step, add 3 over, so one of my two solutions is 3. And in this step, I would divide by negative 7, so one of my two solutions, or the other solution is 0. Okay? So just don't forget GCF. The next set, again, we're not going to do all of these. We'll start with this one. So I would look that it's in standard form. It is, because it's x squared, x, then the constant, and it does equal 0. So what I'm going to do from there is check for a GCF, which it does not have. So I can go straight to my x for factoring, and I need factors of 10 that get me to negative 7. And those factors are going to be a negative 2 and a negative 5. So I'm going to make my factor parentheses. I'm going to drop my x's in there. And x are enough because x times x is x squared. And now I'll ask myself, since these are both x, I'll allow this x to make the negative 2x. So x times a negative 2 makes a negative 2x. and x times a negative 5 makes a negative 5x. And so we factored it completely, and now I'm going to set each factor equal to 0 and then solve. They're just their own little problems. So in this case, one step, add 5 over, so one of the two solutions is 5. And in this one, again, it's one step, add 2 over, so my second solution is 2. So again, what it means is if I did put 5 in here and followed my order of operations, I'd get 0. Or I could put 5 in here, follow the order of operations, and still get 0. As far as the lower section, let's do, for instance, this one. So again, it is in standard form, x squared, x the constant. It equals 0. Looking for a GCF, and it doesn't have one, so I'm going to make my x, and I need factors of negative 12. That will get me to negative 11, and that would give me a 1x and a 12x, with the 12 being negative this time. So here when I make my parentheses and drop my x's in, this time x and x is not enough because x and x make x squared when I multiply them, and I need 3x squared. So I'm going to put a 3. If you liked the 1, put it there, but just make it really light. It's supposed to be an invisible one. So now, if I follow the loops, 1 or x can make either of these. So I'm not focused on that one, but I need to focus on the 3 because 3 can only make negative 12x. So 3 times a negative 4 makes this. And 1x times, or x times a positive 1 makes this. And now I factor completely, set this factor equal to 0, and set this factor equal to 0. And for this one, it's 2 steps. First, I would subtract the 1, which gives me a negative 1 on this side, and then I would divide by 3, so my answer is negative 1/3. So this is our first fraction answer, and just leave it as a fraction. It actually takes more work to turn it into a decimal, and this is a more accurate answer. So in this one, if we just keep that 1 invisible, then it's just one step of adding 4 over. So here are my two solutions. All right, let's jump to page 33. And again, we're not going to do all these examples, but we're going to get most of them. So here, it is in standard form. I just happen to be missing a term, so there's 2 terms. It will be a difference of squares. I am looking for a GCF. I don't see one, but it is a difference of squares, again, because there's difference, and x squared and 25 are perfect squares, which means they have nice square roots. So the square root of x squared is x, and the square root of 25 is 5. So from there, you can make your 2 parentheses of x plus 5 and x minus 5. And now here, set each factor equal to 0 to use the 0 product property. One step, subtract 5, so you get a negative 5, and one step here, add 5, so you get 5. So one thing you can do is leave your answer separate like that, but you can write it as x equals a positive and negative 5, and I want you to start doing that because this is going to pop up when we start to hit some other sections. So there are 2 answers there. There's a positive 5 and there's a negative 5. Let's take a look at this example. So again, it is in standard form. It's just missing its middle term. There is not a GCF, but it is a difference of squares. So the square root of this term is 2x, and the square root of 49 is 7. So from there, I can make a 2x plus 7, a 2x minus 7. And now I can use my 0 product property, set each factor equal to 0, and solve. So in both of them, I'm moving a 7. In this case, I'm going to subtract 7, so that results with a negative 7. But in this one, I would add 7, so that would result in a positive 7 on the other side of the equal sign. And now either way, I'm going to divide by 2, so here I get a negative 7 halves, and here I get a positive 7 halves. But just like before, I want you to start thinking about you can write your answer as a positive and negative 7 halves. Okay? All right, let's get through these last few examples. So on the next final examples, what we're going to do is factor completely. So what I'm going to do is look for GCF and then go from there. So I'm going to pause the video. This video might actually end up being in 2 parts because, well, sometimes that just ends up happening that way.